In this lesson, we will learn how to find the gradients of a straight line. Now, how do we find out how steep this slope is? The formula to find the gradient or the slope is given by rise over run. If you notice, the rise is actually the y-axis and the run is actually the x-axis. So what is the slope of this mountain here? If the rise is 280 meters and the run is 247 meters, the gradient or the slope is equals to 280, which is the rise, over 247, which is the run, and hence the gradient is 1.13. Are the following gradients positive or negative? Yes, it is positive. Now, how do you remember this? Now, if it is going up from left to right, then it is positive. What about this line here? Yes, it is negative, since it is going down from left to right. Now, what about the gradient of this line here? Yes, it is positive. What about this line here? The gradient is undefined because the rise is 6.5 while the run is 0. And you know that anything divided by 0 is undefined. What about the gradient of this horizontal line? Yes, it is 0 because the rise is 0 and the run is 3.5. 0 divided by anything is still 0. How do we find the gradients of a line segment here? First, we need to find the rise and then the run. In order to find the rise here, we shall use the bigger number minus the smaller number, which is 3 minus negative 1. And the answer is 4. The length of the run here is 2 minus negative 3, which is 5. Since gradient is equals to rise over run, it is equals to 4 over 5. The coordinates of these 2 points are 2, 3 and negative 3, negative 1. And hence this point here will be 2, negative 1. Using this as an example, we shall now find the formula for gradients. Let's call this first coordinates x1, y1 and this coordinates x2, y2. And hence this point here will be x1, y2. The rise will be given by y1 minus y2 and the run will be given by x1 minus x2. Since the formula for gradients is equals to rise over run, we will have y1 minus y2 over x1 minus x2. The formula to find the gradients of a line segment given the coordinates of its endpoints is y1 minus y2 over x1 minus x2. It is very important that you take note of this. If you substitute y from the coordinates a first for the numerator, you must also substitute x from the coordinates a first for the denominator. Please memorize this formula by the end of this lesson. Next, if you substitute y from the coordinates b first for the numerator, you must also substitute x from the coordinates b first for the denominator. And hence the formula will be y2 minus y1 over x2 minus x1. Now let's look at an example here. A and B are points on the coordinates plane. Find the gradients of AB. Recall the gradients formula is given by y1 minus y2 over x1 minus x2. Now it does not matter whether this is y1 or whether this is y1. The important thing is that if you start from here for the y coordinates, you must also start from here for the x coordinates. For example, let negative 5 be y1 and 12 be y2. And hence we must let 9 be x1 and negative 7 be x2. Substituting in the values, we will have negative 5 minus 12 over 9 minus negative 7. Pressing the calculator, we will have negative 17 over 16. Or we can do it the other way. 12 minus negative 5 over negative 7 minus 9. We will also get the same answer, negative 17 over 16. Next example, J and K are points on a coordinates plane. Now we are given the gradients of JK, which is negative 12. find the value of A here. We shall first write down the formula for finding gradients. Now you notice that the value for the gradient is given, and hence we will substitute in on the left hand side. Next we shall substitute in the rest of the values here. And hence we have 9 minus negative 3 over 4 minus A. Simplifying the numerator, we have 12 equals to 12 over 4 minus A. Since both sides are single fractions, we shall now cross multiply. On the left hand side, we will have 12 multiplied by 4 minus A, and on the right hand side, we will have 12. Do remember to put the brackets on the left hand side. By expanding, we will have 48 minus 12A equals to 12. Next, we shall minus 48 on both sides, and hence we will have negative 12A equals to negative 36. Finally, we shall divide both sides by negative 12, and we will have A equals to 3. Now, if two lines AB and BQ has the same gradients, what can you say about these two lines? For the purpose of simple explanation, let's assume that these two lines have the same rise over run, and hence AB and PQ has the same slope. In other words, AB and PQ are parallel. Let's look at a slightly different example. If AB and BC has the same gradients, what can you say about points A, B, and C? Now take note that B is a common point in both AB and BC. If AB and BC has the same gradients, both lines are parallel. Now since B is a common point, the lines will look like this. And we can say that ABC lies on a straight line. Or we can say that points A, B, and C are collinear. Now collinear means that the points lies on a straight line. Please do remember this word here because we will use it for subsequent chapters from now on. In summary, we have learned that the distance formula is given by square root of x1 minus x2 square plus y1 minus y2 square. Now do be careful when you put the minus sign and when do you put the plus sign. Next, we learned that the gradient formula is given by y1 minus y2 over x1 minus x2. And the important thing to take notes here is that both the numerator and the denominator must start from the same coordinates. Next, we learned that if AB and PQ are the same gradients, then we can say that both lines are parallel. And if AB and BC has the same gradient, and these two lines have a common point, then we can say that points A, B, and C are collinear, which means that the 3 points lies on a straight line. That's all for this lesson. Do take time to memorize all these points here.